planned for you today, so let's get right to it. We have two panelists here, or from two different companies. First is Roberto Pereira, president of Controall Tecnologia and Automação, our distributor for Brazil, based out of Sao Paulo, and I'll let him introduce himself, as well as Ozm here from Nozomi Networks, who I'm trying to think, do I know Roberto longer or Ozm longer? And I don't know. It's probably around the same time. It's the early 2000s. And Ozm's been for more than 17 years. I was telling Roberto, we first met when he was making custom SCADA systems for oil and gas and water. And from there, of course, going into ICS OT, cybersecurity, federal and Department of Defense, really a key industries that are just complemented well for Opto 22. Then we're going to go into what is Industry 4.0, some cyber attacks, some really terrible stories, but real stories that we did need to be aware of. And lastly, of course, the modern tools of Opto 22, our Groove EPIC and our Groove RIO products. So with that, Roberto, if you're ready, we're ready to learn about you.
Ok, thank you, René. Vamos fazer essa parte agora em português, né? Então, olá a todos. Para apresentar a Controall. Nós fomos fundados em 94, já temos aí mais 28 anos de mercado, quase 29, e a gente vem buscando, como diz aí, sempre uma inovação em cada ano, em cada projeto. A gente sempre tenta inovar, né? René, por favor. Ok. Somos distribuidores da Opto 22, né? Agora já quase 19 anos, com estoque, treinamento em português e suporte local, né? E sempre com uma relação muito forte com a Opto, conseguimos informações e retorno muito rápido de alguma necessidade que o cliente precisa, né? Estamos focados no mercado industrial, eólico, solar, ferroviário e, ultimamente, fortemente no IoT, né? Estamos situados num prédio de 750 metros quadrados na zona norte de São Paulo, próximo à Marginal Tietê. Quem conhece a região de São Paulo sabe, é uma região muito fácil acesso, tanto para clientes e transportadores. Permite que a gente possa acessar, atender aos clientes no Brasil inteiro. É isso. René?
Yeah.
Ok. Aqui acho que voltou.
You're not going to tell us the English parts?
Okay.
So
okay.
Well, I'm sure they get that same part, so I will leave it with your contact information.
Perfect. E aí o nosso contato, né? O Roberto ou o Herbert, que cuida da área técnica, tem os nossos telefones e o e-mail de contato. Então, estamos à disposição caso precise alguma informação. E agora, René, obrigado. Thank you, René. Please continue.
Thank you. I appreciate it. So we're going to jump right into that of what is Industry 4.0. This is where we're at in the current time for the most part. Sure, you've heard Industry 4.0 by now, but we're going to jump right into 3.0 and 4.0 of where the first PLCs coming into market. And now with all the technology that we have, it's physical and protocol interconnectivity between all different devices on a factory floor, any type of project. So because of that, cybersecurity is a primary concern. And this webinar is how to ensure cybersecurity in 4.0 system. And most importantly, what tools are built in that could have prevented some tragic situations in the past. So we'll start off with, I think the most famous one, which was Stuxnet in 2010, which a worm was injected via USB drive, targeted Siemens PLCs that controlled the centrifuges and completely eviscerated a factory. So what we learned from that was that air gap systems were not immune. The Oldsmar water plant, what we learned from that is that you need to separate your different networks. You need to zone them and protect them and not make them outside accessible. And of course, strong and unique passwords for which Azam has a great diagram that he's going to go over that I'm sure you'll enjoy. And lastly is the last two examples. One is Colonial Pipeline. For that, the IT department was compromised, but because they didn't know how bad the ransomware attack was, everything was brought down. And a huge percentage of gas that's brought to the East Coast was put to a standstill because there was no plan. And lastly, to what MIT Technology Review back in 2019 called the most murderous malware, we're going to go over this example specifically, which is of a Saudi Arabia gas plant, and no network segmentation and no help from a manufacturer is what really compounded the problems in this project. And what we learned is strong, unique passwords, unsecured systems, network zoning. You're going to see this a lot as we go through. So it's not just a Brazil problem. It's not just a US problem. It's a worldwide problem. And you'll get a copy of these of this presentation. So don't worry if we go fast by them. But as you'll see, all the different incidents throughout the world. And at this point, Azam, if you're available to go over a little bit of what you guys have found, specifically in the last 6 months, as well as your take on username and passwords, this would be a great time to add that in.
Yeah, absolutely. Well, first of all, thank you for having me on.
Of course.
I really appreciate it. And I'm struggling to really figure out how long I've really known Renee as well. So maybe we met at the same barbershop. Is how far back I can go.
Our hair was hacked.
Right? You presented some good introduction there, Renee. One of the things that we commonly find when we go into industrial control systems environment, could be any sector, it could be water, it could be oil and gas, could be electric, it could be manufacturing. Wherever you go, the number one thing customers always say is, or the people always say is, we're air gap. We're air gap, we don't need it, we're okay. But when we start working in those environments, we find random things like the OEM came in there and put in a wireless access point just so they can remotely service the equipment, right? And we tell them about it and they go, oh yeah, well, we know about that. I'm like, well, then we take a step back and we say like, but then what does air gap mean to you? Right? Maybe your definition of air gap and our definition of air gap is completely different, right? Or what we'll commonly find is vendors are coming in and they're plugging in their laptops to do servicing and equipment, and that's totally fine. But a lot of times people are not aware of it, right? So that's where we get exposure to things like ransomware, because we don't know how things are connected. People typically they think they know, but they've never verified. They've never gone through the exercise to verify the picture in my head and the picture I have on my Excel spreadsheet with the Visio map that I put together. Is that it really accurate or not? Right? Come to find out, it's not. Things change all the time, especially when we talk about Industry 4.0. The connectivity, things are changing all the time, and people, it's just very hard to keep up with that, right? And that's okay, because the primary focus behind Industry 4.0 is to drive business, right? You can't drive business if you start shutting everything down. But the key takeaway there is people have to get discovery to understand how things are connected, and they don't go through that exercise. And that's what we're finding in our research, right? Is for example, if you look at to the lower right, third-party IT provider was the one that was tied in, and that's where that incident occurred, right? Ransomware in hospitals, right? Why is that happening, right? Why are hospitals being targeted? Because they provide critical services, so they can't be shut down. And the attackers know this. They know that if we attack targets like this, they will be quick to pay up and respond. So that's why no matter what industry you're in, having knowledge of what is in your environment, how it's talking to each other, becomes very, very critical. Never always assume we're air gap. have you gone through the exercise to verify that that really is the case or not, right? So that's something I wanted to add to that. And you'll find examples of that. One takeaway from this that I want people to have is look at the different verticals, the different sectors that have been targeted over time. If you're thinking, nobody knows about me, I'll be safe, security by obscurity is no longer tenable, right?
Security by what?
Obscurity, right?
Okay.
If you're thinking, hey, nobody knows about me, who's going to come after me? That's not how, what we're finding is they're looking for targets with the easiest opportunity. It doesn't matter how obscure you think you are. If they think you're an easy target, they'll pick that one first, right? So from here, I'll let you take
I think
away.
they're also, so another thing that you've been seeing, that I've been seeing in the news, is that insurance companies aren't paying for this anymore. Like companies aren't just paying for the ransomware bill now. They're asking for some personal responsibility on the side of the utilities, for example.
Exactly, right. Insurance companies, before when they started, they just wanted the business, so they're offering it. But now they're becoming more and more strict. The requirements are, you have to have done some sort of due diligence, done some sort of risk assessment, for example, right? You must have a history of, like, you've gone through the exercise to verify what your environment looks like. They have some security measures in place. Then we'll give you, the good rates. Otherwise, we're upping our rates because we're not going to take on that liability, right?
Insurance motivated cybersecurity. That's
Right.
good. And this is, to me, the most fun graph on anything that I've ever seen come out of the organization. That's can you explain what this is and why many engineers like myself and our panelists find it so shocking?
It is shocking, especially if you look at it for the very first time. And there's a reason why it is this way. And it doesn't have to stay that way, but there's a reason why it is that way, right? When you talk about industry control systems,
can you explain what this is? Because I don't think it's immediately visible. It's the top username and passwords used from July to December in 2022 for OT space.
Yes, and what I was trying to highlight there is those are common. Those are usually default or factory default usernames and passwords, right?
Yes. And
people either don't know to change them, or they don't want to change them because that means they have to now change them through not just one equipment, but 400 different pieces of equipment, perhaps throughout their environment. And lastly, they don't want to go through the exercise of training the technicians to remember the usernames and passwords. For them, their primary goal is, I just want to do my job. What makes it easier, right?
Well, if I were in a factory and I had access to change the username and passwords, I probably wouldn't change them, because if it's a large organization, I've just promoted myself to OT administrator now, because you change one and you change it for 100 devices. Now, if you need to modify one thing, it's you. So you've given yourself 10 times more work for if there isn't. So like you said, there needs to be a plan in place top down of what's our strategy going to be for that.
Exactly. You couldn't have said it better, right? So, and we're finding that the top to down, the reason this exists is because there's not proper top to down planning, right? Or what we find in a lot of cases too is the top to down planning stops at the IT/OT boundary, right? And the organization at the top think that's where it should end. They don't go further to see that there's a whole different universe that exists beyond that boundary as well, because they're not trained to look for it.
Yeah.
Great.
Well, thank you with that. And that's a great point. Another line in the sand is that IT/OT boundary. From 2022, here's a list also to show you how serious it is of criminal organizations. So we know the criminal organizations, who they are. We know what areas they target. We know what regions they target. And we also, beyond that, we also know how well they're doing or how bad they're doing, depending on, this is basically the ransomware report card that you'll see here. Then you can go into specific HMIs that have been compromised. And here's a list of some of them, some very popular ones here, the Mitsubishi, the Winetex, and then to the PLCs, from everything from the Omrons, Mitsubishis, Siemens, Panasonics, Rockwells. You see it all here. So none of this is private information. None of this is top secret. This is all publicly available information that we're pulling from. And the whole point of this cybersecurity talk and trying to really shock you that it's bad, but B, there are some ready tools ready to help you, is because without cybersecurity, IoT is just the playground for them. So we're going to go into this prime example of what's a burner management system. And this was the system in Saudi Arabia that we discussed, and what should be in two different networks, safety PLC and its engineering workstation HMI, as well as its control PLC. So the control PLC is for the day-to-day operations. For those of you that know, for safety PLCs, this is just to prevent any out of bounds, any death-causing type of activities, just trying to avoid a catastrophe. So this is what makes you, this is your day-to-day, and this is your safety system. So with step one, with a bad actor going through the firewall, downloading, and Azim and his company has a lot of examples of how shell scripts are the top ones used to go in and find these scenarios. So you download the virus to the control engineering workstation. It asks you to upload the control program to it. Step two is now you do a network sweep. So you check everything in your network, what's available. You broadcast, you get device tags, you get all tags from this control PLC. And because it's on the same network, now you're able to jump to the next engineering workstation. That's now the safety engineering workstation. Do the same thing, upload the program, get all the tags. And not mistaken, it's around this point where this safety PLC was the one, Azim, correct me if I'm wrong, where it started, where they didn't do everything right. And that's where the failure started to come up.
Yeah, the only reason this didn't result in catastrophic and loss of life incident was because somewhere along the line, the PLC got stuck and it rebooted. Otherwise, and the attackers were not successful in going through their plan because the PLC, for whatever reason, with that program upload kept rebooting. And then that's when the operators of the plan decided, let's just take this out. Maybe it's bad, right? And they tried to figure out what happened. And eventually, like over the next couple of months, they found out what was happening. It wasn't immediately like to them, like, hey, this got infected, right? Because they had actually sent it to the manufacturer. The manufacturer couldn't find anything wrong. They didn't spend the time. We don't know what the story is there.
Yeah.
But they just shipped them a new one, and then it happened again, right? So this happened over the course of a couple of months. What's really scary here to me, when you look at it, they're using commonly available tools in ISIS environments to do this discovery, right? Like, they're familiar with how ISIS environments are structured. Again, the whole security, biosecurity, who's gonna go into a Rockwell environment, for example? I'm not saying this is a Rockwell environment. I'm just saying, as an example, right? Or who's gonna know about Schneider PLCs? Who's gonna spend the time? They've already spent the time.
Yeah.
Because they know that these targets don't have security built in from the ground up. Typically, they're easy to compromise and they're easy to hold hostage, and they will pay up if that happens, right? Because you want your water to flow. You want people in your town to have electricity. You're not going to say, no, we're going to remediate over the next couple of months while everything is shut down, right?
Yeah. And so it's from this point on, luckily that PLC continued to reboot. Otherwise, what the next step was irreversible for any operator. So it didn't matter if an operator went to any of these PCs, all the plans had been put in place and all communications had come to a stop for him. So at this point, you have all the capabilities of filling that with gas and activating the igniter because there's nothing to stop you, resulting in a terrible, catastrophic, and potential loss of life scenario. And all of this, again, is a documented documented information. And one thing I wanted to add that I thought was frightening, I forget which one of the Russian cyber attacks on the Ukrainian system it was, but it was a known vulnerability in a Siemens breaker that if you sent a UDP packet to 50,000, to port 50,000, you freeze it. And with that one, now all of a sudden you have no protections. And the fact that that was, and this wasn't, and like Ozzy mentioned, this wasn't a secret hack that they found. This was something that was documented, that these bad actors simply scour forum. I would assume they just scour forums and support pages and find problems and then take advantage of it. So with all of that, now I come to the point of explaining of why we put these the top 4 cybersecurity features built into the product that we have behind my shoulder here. And the first one, and you can see how they would have helped in those scenarios. First one is we have a built-in firewall here, and we're going to show in by going into a website. So we can literally close the entire EPIC up. So there's no communication going in. It will not support any inbound communication. The second is TLS SSL encryption. So you can encrypt down at the OT level, which it's not done. No one else. I don't know anyone else that does it at the OT level. Lastly, user management. About you don't have a default username and password, because when you power up one of these, you have to give it a username and password. You don't get a choice at making a default. But now it's up to you and your responsibility to figure out what a safe username and password would be. And then a VPN client capability. So with that, both of our product lines have it, the EPIC and the RIO. You see the EPIC system here. It's fully edge programmable industrial controller. It's like an IPC with IO cards. With this, the remote IO, more fixed IO points, although through USB you can expand, and more a simple system. So again, it stands in the middle now of communicating with whatever your cloud applications, on-premise applications will be, and whatever is physically at the factory on the pipeline, whether it's a PLC, flow computer, or sensor. So let's go back, and this was the complicated, I call this complicated and traditional, but this is how most of the world is still running right now. So from your different sensors through an unencrypted network to a PLC or RTU, through an unencrypted communication to an OPC server, HMI, firewall, gateway, VPN, to cloud. And now what we're showing is that with the EPIC, and here's the thing too, I'll hear a lot of people say, yeah, we can do that with this manufacturer as well. And it's like, okay, how's the firewall? Oh, we'll have to buy the firewall. It's like, okay, how are you going to use your certificate encryption? Oh, well, we'll have a PC next to it that does the, so it's not the same. This is standalone. This you can plug in keyboards, mice to, HDMI card to, and that's your engineering workstation. That could be your operator workstation. So it's now one piece of hardware to the cloud or on premise to all those physical devices. So here in the, I call the traditional complicated method, but it's the method that is now, here are your main weak points that our built-in features take care of. From our system, you have one VPN, one firewall that you're going through. All our communication is encrypted either up or down, and administration of users. So Ozzy can have one master username and password where he can manipulate everything. And I have a username and password where I can just read certain tags, read certain information, and only for a set amount of time. So again, these are the 4 features, the 4 top features. We have several others built into it. And how do you configure them? You don't need to be a Python programmer, C++ programmer. This is Google Chrome. This is Google Chrome that I'm going into, configuring my different rules of firewalls. Here's how I communicate Modbus, and I'll go into the website for this directly. Same thing through Google Chrome. You could use Firefox, whatever browser you want, into the browser, into the web server in this unit, and set up your client and server SSL certificates. Anyone, you can set up your username and passwords, or if they're a Microsoft house, they can use LDAP, and their IT group will be able to manage this EPIC the same way that they manage a new employee coming on board, giving them and segmenting them into certain parts of the network. And lastly, the VPN client over OpenVPN to be able to have that fourth and final way to communicate. So all of that's built in. There's no extra cost to it. That's how you integrate it. And it's for those two, for both of the lines, exactly the same. A little bit about the hardware. It's an industrial quad-core ARM Cortex A9. It's a real-time Linux environment, 22 gigs of usable solid-state drive, fail-safe file system, and look at the temperature rating. So, and here you have all the places to put your mouse, keyboard, and screen too. All agency approvals, so Class 1, Div 2, explosive environments for oil and gas. And lastly, for the RIO, for the smaller system, it's all software configurable IO that you plug directly into it that you can create then those cybersecurity features. So let me jump in here real quick to my, this is my EPIC that I have here over my shoulder. So this is the homepage you'll see on every EPIC and on every RIO system. So if we wanted to go into the VPN, we'd click on network, we'd go to configure, and at the bottom here at the VPN tunnel is where we disable or enable our VPN capabilities. So that's one. If we go to account management, here under users, we can configure the different users that we want to use, or if we, again, are an Active Directory Microsoft environment, here's where we would set up those Active Directory configurations for it. Lastly, for the firewall, I believe that is in security. In security and firewall, here's where we set the different rules of how they're going to communicate. So let's say we had a new SCADA package that was coming in, and that SCADA package, we'll call it SCADA 1, communicated via TCP/IP to port 55,555. And here are our options on how to communicate through physical Ethernet, copper Ethernet 0, copper Ethernet 1, wireless Wi-Fi, Wi-Fi via USB adapter, or the VPN tunnel. So I'll say, no, I only wanted to come in through the VPN tunnel. And there, I've configured my firewall. Lastly, with the certificate capabilities of, you can create the web server certificate for either upstream or downstream, so it's fully encrypted once you are communicating from this device. So that's what it is. And in this same system, you have all the different software of Node-RED, GrooveView, like you're seeing here, the HMI that's included with it, as well as real-time control with either pack control or code assist. And this is it. This is what explains the entire point. We have one solution to talk to your factory. Let's say your factory already has PLCs and where it's running in Industry 3.0 just fine, but you want to send it to Azure. Now, through this EPIC, communicating directly to that PLC, whether through Ethernet, through Profibus, through one of this Mitsubishi protocols, communicating directly to that system, and then injecting it through bidirectional means into Azure, you have that capability. Or directly to a browser over OPC, you're really limitless at that point to make that communication. And lastly, this is where it's all made. This is our factory in Southern California, Temecula, California. It's between Los Angeles and San Diego, in nice and sunny California, except for this year, it's been very rainy. But the point is, we've been vertically integrated before vertically integration was as popular as it is now. So everything is manufactured on this side of our headquarters. All of our offices are on this side, and even OPC, I don't know if you knew this one, Nozomi, the original OPC spec was written in this conference room here, was us, Microsoft, and I forget who else, but the original spec was there. So it's like a museum. I'll be happy
to not know this, but I'm glad I learned that today.
Yeah, that is fascinating to me and true. So with that, I'm going to end the webinar there, and I'd like to thank you all for your time. We're going to, of course, share these PowerPoints with you, and we will take any questions that you have.